Okay, so what we are doing over here is basically in the last day I showed the RAG architecture. Over here is the implementation of it. So what do we do is first you have to give a PDF. Let's say you want to generate answer from a PDF. Okay, so over here I will be mentioning a PDF and it will generate answer from only that PDF document. It will not generate any extra answer or any generic answer. It will generate answer from only that PDF. Okay. So over here, first what I do is I take a sentence transformer. This is a sentence transformer. This model is also known as BERT. Okay. So I take a BERT model. Okay. So first I take a model known as paraphrase mini language model. So I take this from I will show that also from where you can get such models. Okay. Um, so go to this Hugging Face. Okay, over here, you have to search, but you can get many such models like this. Okay. So what I am using is I'm using this one, and it is mentioned clearly how it is to be used. The example is also there. Okay, the examples is also there how to be used. Okay, so I am taking this only paraphrase mini LM L6 V2. Okay, so I take this model. Okay, similar way, I just encode. I take this model, I initialize an object out of it. Then I am using a Cohere LLM. I am not using any public LLM that is there, like your GPT and Gemini. You can use that also, but I am using Cohere. How to use Cohere? Just go to Cohere. Let's say just go over here. You can sign in. You go to API keys and you can just create your trial key, and you can just give a name of an application and it will create a key. Here is my key which I created. Okay, and I am using that key only over here, the key that I have created over here. This is my API key. Okay, so over here I am creating an object for Cohere client, and over here I have created an object for sentence transformer. Sentence transformer will help me to encode the inquiries that I'm doing, encode my the PDF into multiple chunks also. So over here, these two initialization is done. After that, I have created a function which, given a PDF document, okay, given a document, given a docx file or a PDF or a text or a HTML, it will just load that file. So I'm using a relevant loader. Okay, I'm having a HTML. I'm having a HTML loader. I'm having a TXT loader. I'm having a doc loader. I'm having a PDF loader. Okay, I'm giving all the option. Whichever is the path, accordingly the loader will work. Okay, how do we get all these loader? We get all these loader from a tool, an AI tool, an AI library known as LangChain. Okay, so if I go over here and just write LangChain document loader, if I go over here, you will see all the types of loaders, different types of loaders. So there is text loader. Okay. If I go over here, there will be PDF loaders also. See, there is PyPDF loader. Okay. And there is HTML loader, unstructured HTML loader. So I have combined all these loader. and written everything in a else if. Okay. So that any loader comes, it will be able to load the document. Okay. Once the loader is loaded, the loader loads, it just, formats them and, gets the text out of it, basically. The actual text, the actual content out of it. Okay. The content is out. Okay. Now, once the content is out, I'll come back. I'll come to here. Okay. Once the content is there inside my documents, okay, I will take every document and I will split them into multiple chunks. Okay. So let's say this is my document. Okay. This is my website or whatever it is. It's my PDF. It will divide the entire content into chunk one, chunk two, chunk three. So this chunk, I will first encode it. Second, I will encode this chunk. Then I will encode this chunk. Okay. I'm taking the PDF divided into multiple chunks. That's what I'm doing over here. I am taking the PDF. I have mentioned the size of the chunk. The chunk has 100 is the chunk size. Okay, the token size basically. Okay, sorry, 1000. And there has to be some overlap between every chunk, or else the information will be lost, right? Between chunk one and chunk two, there should be some overlapping so that the information continues. The context is there. Okay, or else all of a sudden from a middle of a paragraph the words will start and the model will get confused. So I have chunked over here. I have created a object for chunking. Then I chunk it. I start chunking it. I start passing every document. One document means one page of the document, and it just divides into using this latex text splitter. It just chunks one page into thousand chunks. Okay, let's say there are 4,000 tokens. It will chunk it into chunks then, because one chunk is of 1,000 size. Once I chunk, every chunk will be encoded. Okay, like over here I told, every chunk will be encoded into a matrix format. Okay, it will be mentioned like this, into a matrix like this. It will be every chunk will be converted to a matrix. Like that, this will also be converted to a matrix. Matrix, every chunk. Okay. So once every page will have this embedding, and then I am just appending and creating a big list of these matrices. Okay. Once I create that, okay, I just I also take I also store the source of the document. Like source is the folder path name of the document. That's all. Okay. If you want, you can modify sources to, let's say, storing the URL of the document. You can return the URL also. Okay. From here, I got the answer. Okay. Okay, so once I do that, then I create a vector database. This is how I create a vector database. I take that embeddings which I created over here. Then I first create a object of that index flat L2. I just write like this and I pass this embedding which I created over here. Okay, I just pass this embeddings. Okay, this creates a vector database. This creates this matrix. This creates this entire vector database. This is your vector database. Okay. This is your VDB. Okay. Now what I will do is I'm just storing that vector database in this folder, in this file name, and I also have to store these chunks, because vector database will store the matrix. Once I am fine with a vector database is only used for the context matching. Once I have the context, I have the ID of the context, and I have to find the actual chunk also, right? Then only I can send it to the LLM, right? See, once, okay, vector database is like this. Let's say this is ID 1, 2, 3. Okay, I search what is what is LLM. Let's say the answer comes from ID number 3. So that answer will just have the matrix. What will be the actual value? The actual text. The actual text will come from here. So I have to store this also somewhere, right? This also I have to store somewhere, or else how will I get the answer? Because this will only give the ID. Okay. So that's what I'm doing over here. Okay, I am storing the actual thing in a CSV so that if the vector matches, then I get a answer. Okay. Now I write a for loop, a while loop. Okay. Uh, that enter your query. Okay. Now, if the user enters a query, I am first encoding the query the same way I encoded the each chunk. See, sentence transformer model encode. Similar way, I have to encode the query also. I have to encode the query also. And then I will search inside my vector database. My vector database was this only index. See, I'm searching inside my vector database the query, the embedding of the encoded query I am searching. And I am telling it, please return me top 3 files, top 3 chunks. Okay, it will give you top 3 chunks ID, the index of it, and their distances also. Okay, so what I'm doing over here, let's say I search this, a encoding of this will also be created. A matrix encoding will also be created for this. Okay, a matrix encoding will also be created for this. Okay, so once I have done this, our distance will be searched with this, distance will be searched with this, distance will be searched with this. A distance will be searched with everything. Now from there, let's say it has, let's say I give top 2, give me top 2 results. So top 2 results, let's say is this and this. Okay, these two are my top 2 results. Okay, because the distance from here to here is less compared to distance. So once I get this top 2 results, I take their chunk, the actual corresponding chunk, and I can send that to the LLM. That based on the question, generate answer from these 2 chunks. That's what I am doing here. See, I'm checking a threshold. I have given a threshold distance. The distance should be less than 70. Because if you don't give a threshold, then unnecessary thing also will be written, right? Every time a paragraph will be written. So I have given a threshold also. The distance will also has to be less than, if the distance is greater than 70. Okay, if the distance, then no relevant information found. Please try rephrasing your question. Else, if the distance is found, then I combine those top three documents. Okay, I'm combining them and I'm writing based on the document page, the combined text, whatever I have combined over here. Okay, answer the question which the user asks. Okay, and I use, this is my prompt. I send it to Cohere. See, here is my Cohere prompt. Okay, and whatever Cohere gives as a response, I generate a response. Okay, so over here, this is my PDF. Okay, I'll show you the PDF also. Just a minute, guys. I'm opening the PDF. So here is the PDF. Okay, here is the PDF, guys. Okay, it has a lot of things. So what we'll do, is run this piece of code. Okay, last one was running in infinite loop. Okay, I've interrupted. Okay, let me paste the path of the PDF. This is my path. See, document process for vector database created successfully. Now let me ask a question. Let me ask a question. What is this document about? Let's see what the answer it generates. See, this is basically how you design a chatbot. Okay, it's still working. Let's see. The answer is this document provides a troubleshooting performance issues related to SQL statements. And below are the steps mentioned to solve the problem. SQL monitor report. Okay. So it is giving some of the things. Okay. Now get a SQL monitor report for SQL statement. Okay. Now let me ask another question. I've asked SQL monitor report for SQL statement. Let's see what comes. Yes, according to the provided document, in order to determine a good plan for SQL performance, SQL monitor should report obtained. See, this is how it is generating answer from that. Okay. Now let me ask you relevant. See, I am asking relevant question only. Okay. What are we trying to solve? Okay, this is a point. This is a question. This is a thing that was mentioned in the PDF also. So this is a thing. What are you trying to solve? Okay, let's see what it generates. Let's see what it generates. Primary goal of SQL health check project is to identify and resolve performance issue. SQL is available in 2 versions, ADB friendly, everything. Okay. Is the SQL performance degraded? Yes, according to the document you mentioned, they are trying to address the issue where the SQL performance has been degraded, either with the evidence or not. See, over here also it is mentioned. Issues with the SQL performance has been degraded. So it is mentioning that according to the document, it is degraded. Okay. So this is a random document that I found and I am trying to generate answer. So see, many applications are already using this. This entire thing is basically the code line for RAG. Okay. This is how RAG works actually. Okay. You are basically generating answers from here. I will show you some of the application that exist in the current days, which uses the same architecture. Okay. Just a minute. See, there is something known as, let me share my screen again. There is something known as chat PDF. Okay. You can upload a chat. You can upload a PDF over here and you can start talking to that PDF. This uses the same thing which I told you. So they have built an entire website on top of this. Okay. And I think they answer. So they answer around 1 lakh. So every day, apparently 1 lakh or 10 lakh inquiries are being answered. Okay. This is the top Gen AI app also. I showed you that this application only, basically. This application only. Now if you can you can change the I in the past I used these things also. So you can change the chunk size to get a better accuracy. All those things also you can give it an option. Let's say you build the same tool, similar tool. The biggest example of such tool, so in this case, you are at least uploading the PDF. The biggest example is Perplexity. Okay, if you go to Perplexity, Perplexity also uses the same thing only. Okay, so Perplexity is also generating answers from various links. So instead of PDF, okay, Perplexity is generating answer from HTML pages, from URLs. Okay, Perplexity is also using the same concept. If you read about Perplexity, they are the first such a big scale RAG application. Okay, they are instead of PDF, they are searching URLs basically. We were doing PDFs. They have created a repository of all the URLs in the world. And obviously, they have built some complexity on top of that also. But the best application is Chat PDF, which I showed you. Okay. So now you can also build your Chat PDF system. And obviously, you have to build a UI, UX, give more options to, premiumize it and, charge more. So this is the entire application. This is the RAG architecture. This is the coding part of RAG architecture. Now I am open to questions, guys, with respect to RAG application. Okay, if nothing is there, then probably I will share this piece of code also to all of you. Okay, we can wrap up. So this is the entire application that currently people are building, and you will see a lot of LinkedIn posts around this only. So guys, grabbing a technology, like understanding the concept will help you a lot, because the other concept that you require is fine tuning. So there are three things that are now becoming very popular in the world of AI. That is, one is RAG, second is fine tuning, third is agents. Someday we will do those also. Okay. For now, guys, try to build this RAG application. Okay. And you can use your API key as well, by the way. Okay. Okay. Okay, guys. Then bye, everyone. Thank you.